Welcome to this webinar. It's on P2 and metal fabricating and finishing. And oh, here we go. So some workshop logistics. If you would please keep your camera off and mute your mic or your phone. We will have question and answers at the end of the workshop, at which time you will be free to use your camera, your mic, and phones, however you've joined today. We will not record that part of the session, so we wanted to give you some anonymity to be able to feel free to ask any questions that you want, and know that that wasn't going to be part of the recorded session and made public. If you're having trouble seeing the screen, I'm going to join by video because I should be on here so you can see me. You should adjust your screen so you can see the presentation and see just me, a little bit of me in the corner. If you're having trouble with that, you might message Allison and she can give you specific directions on how to adjust your Zoom. And as I said, this session is being recorded and it will be available in a few weeks. So let's get started. Today's speakers, I'm Linnell Ladd with K-State PPI. I'm the P2 intern coordinator. And my topics during this part of the presentation is going to be on metal fab and TRI, P2 opportunities that we've seen in the past. So I'm going to go over some findings that we've identified working with companies in Kansas. And this includes energy, waste, and water, stormwater, and hazardous materials reductions. Also with us today is Dr. Kathleen Wolf. She's a consultant with industry. If she wants to jump on real quick and introduce herself.
Hi, everyone. I'm Katy Wolf, and my expertise is in solvent alternatives, so I'll be talking about that today.
Thanks, Katy. So I wanted to start out today talking about the toxic release inventory. Many of the companies that we work with do not have to submit to the toxic release inventory, but it is a really great way to look overall at your industry type and the types of releases that companies like you, or it could be you, are releasing into the environment and how those are being reported. And also the TRI has a functionality to report pollution prevention activities or source reduction activities. So I'm going to open up EPA's website and hopefully everyone can see this. It's a nice opportunity for me to show you the functionality and how you can use this to track what you're doing, what is released at your facility, what other companies are reporting, and just kind of do a comparison because it is a competitive world out there. So I'm going to choose Kansas. We're just going to look at Kansas overall. I'm not going to look at individual industry types, but what I want to do is just give you an overview of what the tool does and what you can look at in this tool. So these are all TRI facilities in Kansas, and you can see, you can hover over the dots and you can see that they are different industries all over Kansas that have to report to TRI. A lot of these are not in your industry sector. So to really drill down into that, we need to, utilize some other functions of this TRI database. But for right now, just to look at an overview of the total facilities in Kansas that report to TRI, there are only 322 companies in all of Kansas that are required to report to TRI. So that's not a big number because we know that in Kansas, there's a lot more companies. There's a lot more business in Kansas than just 322 industries. But this is just an overview of the total emissions that are reported and as released from the industries that are required to report. And we could drill down even farther if we wanted to. We could look at the top 10 facilities in Kansas and their releases and how they're released. So light blue is air releases. This color, orange, is an off-site release. And, you know, we have land and we have water releases. And then we have, you know, the list of the names of the companies. And this allows you to look at their total releases in 2020. Their RISI score, which some of you may not be familiar with what RISI is, but it's an EPA tool that looks at, it's a risk screening environmental indicator. And the higher the number you have, the higher, you know, the risk is. And this is talking about, you know, people who live in the area and exposures to the releases that come from the facility. EJ report, maybe recently you all have heard some little rumblings about EJ and how the focus, EPA and other agencies of the federal government and state agencies are starting to really take notice of EJ issues. And so you could utilize this tool to link you back to EJ screen and look at, you know, if your facility or if this facility is located in an EJ community. And you can look at the specific facility reports from here. But because we're here to look at your industry type, I want to drill down a little closer and just show you some data that is related specifically to your industry type. So let's go to the TriToxics Tracker. And if this doesn't show up, or if sometimes I have to stop sharing and reshare again, but let me know if I need to do that, please. So I'm going to continue, and this is, when I say this, I had a overall state-wide, overall facility-wide search previously. I'm going to start by continuing with that, and you can see that this is for reporting years 2018 through 2020 and includes 352 facilities with 157 chemicals reported. But let's drill down and let's look at sector. So if I hit on this, I'm going to be able to choose industry sectors, which is based on NAICS codes. And over here is the national emphasis areas that in the P2 program. So EPA's P2 program has national emphasis areas. And these areas that they have chosen are food and beverage, automotive, aerospace, metal manufacturing and fabrication, which is you, chemical manufacturers and pharmaceuticals. So if I want to drill down specifically to the companies that have to report in TRI that are metal manufacturers that have the the NAICS code 331 or 332, I'm going to choose this. And I'll come down here and I'll say, I want the most recent year, which would be 2020, just to keep it more relevant. And I will hit search. So what we'll see now is that map that we were looking at earlier has been narrowed down to just facilities that are in that specific 331 and 332 NAICS codes. So you can see we could highlight here what those industries are if we wanted to hover over, and we could identify who these companies are. And we can look at by color, you know, it gives you an idea of what their total releases are in pounds based on their most recent report. So here we have 44 facilities in Kansas that are in the metal fabricating NAICS codes and are having to report to TRI. From here, we can start drilling down and looking at more specific data. We can look at an overall summary, which will give you, you know, demographic information, and this links back to EJ information. We can look at the top facilities. The top 10 facilities are listed here, and the types of chemical that they're releasing or reporting has been released. So that's all here. And you could get another facilities list, so you could look at it a little differently from a different perspective. This table you can download, and then you can find out compliance and enforcement information. So if you are a company that has to report to TRI, you want to understand how your data is being presented here in this reporting function. That way, you know what the public can see and what your competitors can see as well. So if we want to look at the total releases that were reported in 2020 from these 44 facilities, I could click on this, and it's going to give me some really nice graphs to look at. So up here, we see that these 44 facilities reported that they had, you know, almost 770,000 pounds of materials released that they were required to report. A little over 84,000 of that was in air releases. Nothing was reported as a water release. We had some land releases and some off-site releases in these numbers. So here, I just wanted to let you see how these are defined. Hopefully you can see this. I just verify for me someone that you can see the definitions of what is an air release, what is a water release.
Yes, we can see that.
Okay, good. So we're talking about, you know, things that are emitted, you know, from your stacks at the facility, or non-point sources such as leaks or fugitive emissions. The water releases are discharged to bodies of water such as streams and rivers and runoff. Land releases are types of disposal such as into the landfill, surface impoundments, or underground injection wells. And then offsite means those were transported to another facility for a recycling, energy recovery, treatment, or disposal. So this could include, you know, the materials that you recycle, like the metals. This could include the hazardous waste that you send off to be treated. And when we look at this, you know, these are just, again, the nice graphs giving you a visual of, you know, percentage, how much was disposed of to land, how much was offsite, how much of it is air emissions. And then you can see the specific chemicals, manganese being one of the biggest ones, right? Because you'll never get away from that. That is part of the material. I mean, that is your metal, that is your raw material. You find it in your welding wire, your welding rods. Technically, we have not been able to find a way to get away from some of these chemicals that have to be reported, like chromium, zinc compounds, copper. Here's TCE, and that's something that Katie's going to probably touch on here in a little while. And different things like styrene, we know that would be found probably in paints or adhesives and things like that, and glycol ethers. So just to give you an idea of what emissions are coming or what's being reported by the industry that you're in TRI in Kansas. So again, you know, this is by chemical, just a different way to view it. Most of it is manganese. Then you have these other constituents too. By industry sector, you can drill down. This is going to show you, is it the 331 or is it the 332 that has the most releases? And right now it looks like the 331 companies are the ones in this NAICS code that are reporting the most releases that's been reported. This just allows you to look at all of those at one time, but it gives you an overall picture of what's released. We could look at waste managed. So from this perspective, again, we're using some terminology here. Recycling, we're recovering that material. Energy recovery, it's being used to produce heat or energy, or like electricity. Treatment means it's being destroyed. So, you know, a lot of the hazardous waste in Kansas ends up, you know, being treated for hazardous waste and used as hazardous waste derived fuel in cement kilns, for instance. So, you know, that would be treatment. And then we have disposal or other releases. So this is toxic chemicals that enter the environment and are disposed of at a landfill or other surface impoundment again. So here are the numbers of waste managed in with these 44 facilities in Kansas that are under these 31 331, 332 NAICS codes. And we can see that a lot of it is recycled, and we have a little bit that's energy recovered, which is great. If we could increase this, this is a really great opportunity where we could find it to increase source reduction and improve pollution prevention strategies. So treatment, of course, is not P2, and neither is disposal. But at least on this part of it, this would be considered P2. Recycling, no. Unfortunately, EPA does not consider recycling to be a P2 activity. But we can see these graphs. Again, these are just nice visual representations. I feel like it lets you know that a lot of this is being recycled. And what is being recycled from your industry type? Copper, chromium, manganese, nickel, lead. So, and you would that makes sense, right? Because that is your raw material. So if you've got a sheet of steel that you're cutting shapes with your plasma cutter, you're going to have some leftover that can't be used that you're going to end up putting into recycling, hopefully, and that it's not going to the landfill. But again, it's just, we can look at all of the charts and, we can see each one of these and break it down into the chemicals, constituents, little better visuals, and things like that. And the other thing, we have waste transfers. We have some things that drill down a little further into chemicals. But before we move on, I wanted to highlight that this is an opportunity for these companies to indicate their pollution prevention strategies that they're employing to reduce their releases. So, hopefully in the future, they no longer have to report to TRI, right? I mean, that would be an optimal goal. But here, out of 44 facilities, we have one facility that has reported a source reduction action. And we have 3 activities reported by this one facility. We have 7 reports, though, of barriers to P2, and then they provided comments. What are those barriers to implementing P2 in your industry? So let's look at that, because that could be pretty interesting. Here in Kansas, the one company that reported P2 action that helped reduce their releases, it was good operating practices. So, there's not a lot of data here. What is a good operating practice? That would be nice to know. The barriers seem to be, and I'm going to let this refresh because it's not showing up. They're saying that, they're maxed out on their process. They have no substitutions that they can employ. There's no alternative that they're aware of that they can use instead of what they're using that they have to report as a release. And then there's other. So let's see if we can find out a little more about this. I'm going to look at the list of comments, and we didn't have any comments for source reduction. And no, I'm sorry, we do have they just took long to show up. Sorry. We have these comments for source reduction and barrier. So here we have 3 comments here that say that the barrier to P2 is they already implemented some P2 actions, and they do not see that additional reductions are technically or economically feasible, or they have no known substitutes or alternative technologies. Now that's really interesting because, and that's why we are here at PPI, because we try to help companies find these substitutions or alternative technologies. And Katie's going to talk a lot about some opportunities here in a little bit that fall right under that line of providing those alternative technologies. Now, if I hit all comments, I think we get these and just maybe a few more. I'll let it load. And here again, we get, source reduction is not applicable. And we can look at what chemicals are related to that comment. So here we have no substitute known. Here we have that the source reduction is not applicable. So in other words, maybe it's the material they're using. It's stainless steel. It's got chromium in it. It's got manganese in it. It's got nickel in it. It's got zinc in it. how do you replace your raw material? You maybe can't. So, you know, I can't speak for this company, but this is just an example of that makes sense to me, that those are in that product. That's your raw material. There really isn't a source reduction action that you can take to reduce this, because it's something that is coming from just the fact that this is your raw materials that you use. But I wanted to just highlight that we do have source reduction opportunities. And this is one of the reasons why this industry type is listed as, you know, one of the focuses in EPA's national emphasis area, because they see that there is a lot of opportunity for companies like you to implement pollution prevention. And again, that's why we're here today, is to talk a little bit more about that, and actually, you know, show you some examples of some simple things that maybe you could get you thinking about what you can do in your industry. I spent a lot of time. This was just in case I could not pull up and show you the internet. I just wanted to make sure I had those locked in. Now let's talk about energy opportunities. And a lot of people say, well, this is low hanging fruit. Just about everyone knows about, you know, opportunities to reduce their energy usage, or, you know, change their process to reduce energy use. But one of the big ones that we help companies with and help companies identify, it's really pretty simple, is, you know, compressed air leaks. And so I just wanted to start out with that topic and just give you an idea of what it costs to operate your compressed air unit every year. So this is from FS Elliott, and they have a how to calculate your compressed air energy costs. And they gave this example, and it's really, I think, an excellent example to use. So when your unit is fully loaded, if you had a 200 horsepower compressor rated at 215, and this would be brake power, I believe, that operates for 8,000 hours annually. So this number I want you to think about a little bit. A lot of people were like, well, we only run one shift. Are you shutting off the compressor? You know, that's something to think about. If you're not shutting off the compressor every day at the end of the shift, there's a possibility that it is actually running this many hours. And then what we're going to talk about next, this becomes maybe a really huge draw on your electric bill. So let's think about this for a minute. And then there's a nameplate service factor that you probably should be able to find on your compressor. And then just assuming that it's loaded 85% of the time with a 95% motor efficiency. And then the rest of the time it's not fully loaded, you know. So then here's the cost. Here in Kansas, this might be a little cheaper. Like I said, I took this example from this website. So cost when fully loaded, you might be spending over $100,000 a year just to operate this compressor on your energy bill. When it's partially loaded, it would be, you know, quite significantly less than this. So why is it important to kind of understand this? Well, with compressed air, you're going to have energy loss. Your compressed air units, you know, they operate on demand, and sometimes they're undersized. So they're just running, and they can't keep up with demand. Or due to poor maintenance, there's holes, you know, with the either you're not maintaining the compressor efficiently, or you're not maintaining, you know, maintenance on your hoses, connectors, lines, or even the air tools. You know, they could be leaking all the time while they're sitting there and the compressor's running. You may not have air storage, which could help, you know, save some air and reduce the use of the compressor. And, you know, sometimes we see employees in the workplace misusing air. So it's important to train employees, you know, what's the appropriate use of compressed air. In this example is a bleed or a blowdown. This company did not have a dryer on their compressors, so moisture would build up in the line, and they would open the lines every so often to kind of let on these blowdown line parts of the system, let the water out, because if you have water in your lines with the air and it gets to your tools, your tools are not going to function correctly. So we looked at this, an intern looked at this, and the company operates on 2 shifts, and the other time it's the compressor is shut down, and they had 6 blowdown valves that they always kept kind of partially open. So you had this constant leak of air, and it ended up being a $1,817 of an annual cost. And it was, using 39,000 kilowatts of energy. So, if they had these wide open, or it would be a lot higher, or, the investment to look into purchasing a dryer to add onto the system, you would have to look at the cost of that and calculate the savings over time. What would you be saving? And the student did look at that, and they were in the future possibly going to have to replace some of their compressors, and we're going to buy compressors that had dryer units. So this would solve this problem. But throughout the facility, we looked and we found other leaks, that were occurring, and it all added up to some pretty big numbers. So for instance, last year, our interns were at several industries that have metal fabricating activities or are considered metal fabricators. And, this is not unusual. This is not a blight on the company or anything. It's whenever you're using compressed air and you have a rubber hose that's running against cut metal, you're going to get holes in your hose. And just this, one little snapshot, we found 33 leaks at one company, 30 at another, and the circuit rider looked at 6 different facilities and found leaks. So this one would be, this is one facility, this is another, and you can see that depending on, the leaks and how many are identified and the size of the leaks, how much air is being lost, you can get some pretty substantial savings over a year's time if you would repair those leaks once they're identified. And that's something that our interns can do. Our circuit rider intern can go into a smaller facility and do this type of work in one day and identify the leaks for you with a UE Systems ultrasonic leak detector is what we use. But, this is some substantial findings, and it also helps, save electricity for the company. Lighting is another area where we have a great opportunity to save. Again, it's low-hanging fruit. So, when we're talking about saving money and, changing to LED, plug and play is the cheapest way to go. If you're going to have to change out your fixtures or ballasts and things like that, then we get into a little more capital cost, a little bit extension of the return on investment. But it's, those are things that our students look at and can calculate for you. Occupancy sensors, I'm just kidding here, not really, but they're not just for boardrooms and bathrooms anymore. We looked at a very large storage area where the lights are on 24/7 and people are not in there 24/7. So an occupancy sensor in that area was going to, reduce, save, 8,395 hours a year of those lights being on. And that was going to be 10,947 kilowatt hours of energy. It's small savings, but I mean, the return on investment just to install these 2 sensors were only going to cost $126. And so, it's like 0.14 years a return on investment, but at least the lights aren't on all the time if they don't need to be. Fuel usage is another area that we like to help companies look into. The different fuel types you might be using in industry, right sizing your equipment, looking at your building envelope and your process areas. And when I say process areas, maybe you have an area that has to be climate controlled and another area that's not. And so that heat loss between those 2 areas can be very critical and may increase your fuel usage in the winter and your electric in the summer. Shipping and receiving doors are notorious. They don't always close fully. People leave them open, you know, while they're moving materials in and out. And one of the things that's been brought to my attention recently is the winter storm that we had last year, where the temperatures were just frigid. Those surcharges are starting to show up on people's fuel bills. So, you know, changing your fuel type, if you can get away from using a natural gas or a fuel oil and go with electric, that is going to make things more efficient at your facility. It's going to reduce your costs. And right sizing equipment is also important. We worked with CST Storage. They've been a great partner with us for many years with our intern program. And they put in a new right-sized water heating system. So they had some oversized heaters. And so the ratings on those burners were too high really for the system. And they right-sized that, and they reduced their natural gas usage by over 700,000 cubic feet of natural gas. It also helped them save over 660,000 gallons of water. And it was a cost savings of $13,000. So they implemented this, and it has really improved their process. So I just mentioned a water usage or water savings. Let's look at that real quick. I wanted to make sure people were aware that there is some assistance and some guidance on EPA's website as well about, you know, water usage and metal finishing. So this is a guidance document that you can find. It's brand new. It was just issued in this month of this year. I'll take you there real quick just so you can, you know, if you want to look this up later, we have it linked on our webpage. But it is a really good overall guidance document about, you know, metal finishing shops and when you have to utilize these metal ion bearing solutions that contain, you know, chromium, zinc, nickel, and other metals. And Katie may touch on this, I'm not sure, but this is a really great, you know, information and document for, you know, you to review and read. I won't cover it here because I just don't have time to go through the whole entire document. So, you know, wastewater is always, you know, something to focus on. And when you have a water treatment system, because you have to, because the constituents of your wastewater is like contains chromium, let's say, you know, you want to make sure you're operating that system optimally, you know, how it was designed. Make sure you're doing preventative maintenance on that system, and also training your employees on how to operate your water treatment system. So one of our interns last year was a circuit rider, looked at a company that they had a water treatment system in, but it wasn't being operated properly. And the employees had not been trained on how to operate this water treatment system. And it was from one of their plating tanks. And so they were looking at a recycle rate was 10%, and the effluent rate was 18 to 25 gallons per minute. And it depended on how who was operator that week or that day. And by just training the employees on proper operation, they were able to increase recycling rate to 50%. And they kind of, you know, directed the employees, let's set this at 18 gallons per minute. And they reduced the virgin and fluent water. So clean water input was reduced by over 46,000 gallons per year. It would save $7,874 in fresh water costs, and close to, you know, just a little over 24,000 in sewer costs. That's pretty big savings, just a little tweak and some employee training. That doesn't take a huge investment. I threw this in here just because we saw a lot of industrial stormwater situations last summer with our interns. And I wanted to make sure that everyone's aware that, you know, industrial stormwater permitting is you know, it's called the pollution prevention plan that you have with an industrial stormwater permit. but it's not P2, it is regulatory. And so it's the minimum of things that you have to meet if you fall under this category. And most everyone that's in the major source group 3.3 of the SIC code, which would be the NAICS 331 and 332, need to look at your stormwater discharge potential and evaluate if you need to obtain a permit and what you need to do there. So, you know, this is just a list of, sorry about that, of the major pollutants that you would see in this group setting of these NAICS in your occupation, and why they would be of concern. And, you know, the type of activities that you might see where this could end up being a stormwater concern. So if you're storing material outside, if you have equipment, you know, like your trucks and things like that are outside, and your fueling areas outside and is not contained. If you have waste storage, so like hazardous waste storage outside and it's not covered or contained. And, you know, if you have illicit discharges. So over here would be an example of the things, you know, it's when you're storing your products outside, it could be your scrap, it could be your final product. You might have drums that contain the fuel oils that you use or the lubricants that you use. If you're storing your emissions, you're like from a bag house that's been captured and you're storing that outside and it's not covered or contained, that could be a source of stormwater pollution. So I just wanted to bring this to everyone's attention so that we could know that this is a requirement that needs to be addressed in many situations.
Preventative Nell, you've got about 5 minutes left.
Okay, I'm going to rush through this so you guys can see this. I won't stake on this very long because what I really want to get to is hazardous materials. So when we're talking about hazardous materials, I wanted you guys to be aware that we do have some really short and succinct, concise videos that deal with SDS and how to use your SDS to identify what's in the raw materials that you're using at your facility. We have a video on chemical replacement strategies, chemical inventory management, and process change. And I'm just going to show you where it is on our website real quick. We have a lot of P2 resources. This is the P2 pollution tab that talks about our intern program and applications for businesses and students. And we have technical assistance information. We have all of our case studies from all of the intern work that's been done. Some of our intern case studies have presentation videos that go along with the case study that you might be interested in watching, especially if it's an industry type you're wanting to learn more about what they're doing. We have a news page that basically you know, has kind of some of the latest things going on, EPA information that might be of interest to you, and other resources. And that's where our videos are. Hopefully you have access to YouTube, because if you click on these, it takes you to YouTube. Last year we had another best practices in the metal fabricating industries in a P2 workshop that we recorded, and you can watch here. We have some information about TCE, and then Region 7 has a pollution prevention roundtable, and all of our agendas and notes from our meetings are found here if you're interested in looking into that. But I wanted to make sure you were aware that we have a lot of resources, and we're trying to build those resources all the time. So if you haven't heard, and I want to make sure that we cover this, EPA has added a new hazardous air pollutant to the hazardous air pollutant list. 1-bromopropane, or 1-BP, also known as N-propyl bromide, or NBP, it has been added, and it went into effect February 4th. So it is a HAP, and right now there is no NESHAP or MAC standards that cover this. So they will be investigating whether or not to add this into already existing NESHAPs, or whether they will be creating a NESHAP perhaps to cover this. And this may be something that Katy will talk about here in a minute as well. Also, because it is a hazardous air pollutant, you now need to be tracking it and adding that into your total HAP emissions. So I just wanted to make sure that even though there are not any niche apps yet that would be applicable, you will be required to track it for your total HAPs. So whether that is, if you're an area source or a major source, you're going to have to put that into your total HAPs calculations for your air emissions. EPA has some more question and answer document on their website. We can make this available to attendees at the end so that you guys have access to these links that I'm showing you. And an example of, reducing the hazardous materials. So we're not just talking about air emissions, we could be talking about hazardous waste. And this was an action by a facility that was a combination attempt, 2 activities, reducing their air emissions and reducing their hazardous waste at the same time. And it had to do with their paintings and coatings and their solvents that they used. So they installed a solvent reclamation unit that was closed loop, and it was going to reduce their virgin material purchase by 6,600 pounds. And it was a cost savings of $15,000. The installation cost was $19,000. So the return on investment was just a little over a year for that. And then on the painting side, they put in some new paint lines, installed more efficient spray guns. They invested in employee training so that employees could apply paints more efficiently to parts. This ended up reducing their emissions by 31,000 pounds a year. It reduced their purchasing or their input of hazardous materials by 4,000 or almost 5,000 pounds per year. This was a cost savings of over $250,000. And, the new paint lines and the employee training and everything cost around $225,000, dollars. And that return on investment was less than a year. So some of these activities that you can do at your company, once you do a little investigation, do the math, you'll find out that you're reducing emissions and it is a huge cost benefit for your company. Chemical inventory strategy, when you have to worry about chemicals that you have that expire, that maybe you have supply chain difficulty obtaining. So if they do have expiration dates, you don't want to order too much, but you have to order some, right? Because of supply chain issues now. And the other concern is maybe, storage and understanding compatibilities. So as we go along, the strategy here, this was at a company that had some sealants that were like a 2-part sealant, and they had expiration dates. So how they were being stored, it was just sort of a haphazard. They had new and old sealants intermixed. And so there was expired sealants mixed in with brand new sealant, and employees would pick it up and they'd see that it was expired, and it would just go to the hazardous waste bin. So now, they are wasting, 184 pounds of sealant on every month, which was costing $3,200 in wasted material. But by going into a first in, first out system, where they got a little more organized with their sealant, they were able to save a lot of money on this process and prevent waste of sealant. Also, one of the things I want to talk about, and I know I'm kind of rushing through this and I'm so sorry, just give me a few more minutes. Funding your P2 projects. We hear a lot from companies that they would love to do the projects that we have recommended, but maybe right now the funding is not there. I mean, we realize that, your operations are first, and then some of these projects, the funding for that is, it may take a couple of years, 2, 3, 4 years before you get the approval to actually implement the projects. But EPA has issued some new information about P2 financing opportunities. And there's some, you know, a PDF that's a little tip sheet on, you know, how to finance your P2 projects. And they also have, you know, some links to commercial funding, government resources and programs, and, you know, green banks. These are banks that finance green industrial processes. So I know I'm rushing through this. I feel, but, you know, you can always talk with us, and we're working to also investigate ways for our companies that we work with to finance the P2 projects that we've recommended, because we feel it's important when we identify such, you know, these cost savings numbers and this reduction in pollution, and then we're unable to help you find funding for it. We feel really bad. So we want to try to link you up with financing opportunities if we can find them. I wanted to make you all aware, and maybe Katy will mention this too. I know she was going to talk about some other upcoming trainings, I think, in Nevada. But the Nevada Green Business Network has a series of 9 videos and certifications, and I'll get you this link. These are really good videos about your industry type and P2 opportunities. And you do get a certification from them for attending these. You can get that certification. And that's really the end of my presentation. I wanted to let you know that, you know, how we can help. We have the Small Business Environmental Assistance Program here at K-State PPI. This program works with companies that are less than 100 employees. And, you know, we provide free and confidential technical services that deal with environmental and P2. We also have our P2 intern program and technical assistance program. Your employee size, your company size is not an issue here. We have full-time interns, and we have a circuit rider intern that works with smaller companies like that would fit under the Small Business Environmental Assistance Program services. So, you know, anyone can contact me, or, you know, just call our 800 number listed here, or email us at sbeep@ksu.edu. And with that, I am going to turn this over to Katy.
Okay, let me see here. Sorry. Can people see my screen?
Yes.
Oh, good. I'll do full screen. Sorry.
There you go.
All right. Okay, so hi everyone, and I'm going to talk about case studies of safer alternatives to vapor degreasing solvents today. And as many of you know, there are a whole range of different types of operations that rely on vapor degreasing, and they include some of those types of operations that I've listed here: metals processing, electronics, aerospace, and other types of precision operations. And the solvents that are most commonly used in vapor degreasing include the 4 that I've listed here. And they are the 3 chlorinated solvents: trichloroethylene or TCE, perchloroethylene or methylene chloride or MC. And then, as Linnell mentioned, N-propylbromide is another solvent, and it's a brominated solvent. And I call it N-propylbromide, not 1-bromopropane. Nobody in industry calls it 1-bromopropane. So the conversion process that I'm going to discuss, the safer alternatives that I'm going to discuss, they're really appropriate for applications using any of these solvents. So I worked with 9 different companies for the case studies I'm going to discuss, and 6 of these companies were included in 2 projects that I completed very recently. There were 4 companies in a project I worked on with the Pollution Prevention Resource Center, and that's in the Seattle area. And that project was sponsored by EPA under the P2 program. And I also worked with 2 companies in a project sponsored by the Hazard Evaluation System and Information Service, or HESIS, and they're part of the California Department of Public Health. And in all 6 cases, the companies were using N-propyl bromide, the solvent that Linnell mentioned. And that isn't really very surprising, since a lot of regulatory agencies and pollution prevention providers have recommended that companies switch away from the 3 chlorinated solvents to N-propyl bromide in the last decade or so. The chlorinateds have been more heavily regulated, so N-propyl bromide is now a HAP, so it's more regulated at this point. And it was always a problem. It is a carcinogen like the other 3 solvents. Now, half of the companies I worked with ended up converting to the alternatives. And I did complete work with the other half of the companies, but they didn't make the conversion in the time frame of the project. Now, I also began an independent project more recently, and I'm working on it on a pro bono basis. And it involves a trichloroethylene vapor degreaser, and we're partway through the testing of alternatives. So I'm going to talk about that one as well. Now, the remaining 2 case studies I'll discuss are companies I worked with a number of years ago, and I worked with them when I had my nonprofit organization. It was called the Institute for Research and Technical Assistance, or IRTA, and that was in the Los Angeles area. And the 2 companies I worked with there used trichloroethylene. And the cost data for those companies was updated about 5 years ago. So that means it's probably outdated today, but the relative costs are probably still viable. So I wanted to include those case studies here as well. So the first case study I'll talk about is a company called Mapsco in the Seattle area. This company offers non-destructive testing services to aerospace companies. And the type of non-destructive testing the company performs is called magnetic particle inspection. In that type of inspection, you use a fluid that contains magnetic particles and you magnetize it. You then place the part in the fluid, and if there's a flaw or crack in that part, the magnetic particles line up next to it, so you can identify where it is and you can repair the part instead of getting rid of it, which is really good. So historically, the company used a large N-propyl bromide vapor degreaser for cleaning the parts. And it was something like 130 gallons. And so we tested the company's parts with a water cleaner supplier, a company called Brulin. They have very good water-based cleaners. And we identified a suitable cleaner that the company was actually already using in other parts of their facility. And the parts were cleaned effectively in the Brulin lab in an immersion agitation system. So accordingly, I sent in an equipment manufacturer to quote the cost of a new system of this type, but the company felt that the cost was too high. So Mapsco then found a secondhand system, but another company purchased it before they could get it. So I got in gear and found another place that was offering a secondhand system of the type that was originally quoted. And Mapsco ended up buying it, and they've been using it probably for over a year now. So this slide shows a picture up in the top left-hand corner of the non-destructive testing stand. And the vapor degreaser is shown in the picture on the right. It's that large one of 130 gallons or so. And the bottom picture shows the water cleaning system the company purchased. And it has a wash, a rinse, and a dry section. And as you may be able to see from the picture, it also has an automated system for indexing the baskets from one bath to the next. Now this slide shows the annualized cost comparison for Mapsco, and I generally tend to use an annualized cost for comparing the cost of using the vapor degreaser on the one hand and the cost of using the water-based cleaning system on the other hand, because it's pretty straightforward to understand that, a yearly cost. And I'm really not going to be able to discuss the assumptions I made for every element that went into this cost analysis for Mapsco or for the other case study companies I discussed today, because it would really take too long and it's also kind of boring. And I wanted to go over a bunch of different case studies instead. So I do discuss these assumptions for 4 of the case studies in much more detail in the PPRC document I referenced earlier. I showed you the link on an earlier slide. And I also discussed the assumptions I made for the cost analysis for the last 2 case studies I'll present in a document on my old IRTA website. And I'll give you the address for that website on the last slide. I wanted to, again, to include as many case studies as possible here because I wanted to give you a flavor for the range of different types of operations that can find safer alternatives. So back to the Mapsco cost slide, as you can see from the total cost figures, Mapsco reduced their total cost of cleaning by 26% by converting to the water cleaning system. Now, the second company I'll discuss is a company called Exotic Metals Forming. They make ducting of all kinds for aerospace and industrial applications. The company used a large N-propyl bromide vapor degreaser for many years. And Exotic is subject to a lot of aerospace requirements, and they're also subject to the European Union REACH requirements. And I learned a lot about those requirements when I worked with Exotic. And in some cases, the REACH requirements are more stringent than things that we have here in the US. And in other cases, they're less stringent. So you have to be on top of it, kind of. We did testing with a water cleaner supplier, and we identified a good alternative. And the company did end up converting to that cleaner for this operation and also most of the other water cleaning operations in the facility. And the company was able to use one of their existing immersion agitation systems for cleaning the parts that had gone through the vapor degreaser previously. So they didn't even have to purchase a new cleaning system, and they saved a lot of money by that. We also worked on a related process that involved using an anti-spatter product in a laser cutting operation. People also use these anti-spatter products in welding operations, so they use the same types of materials. And a lot of times when I work with companies, there are related operations that arise that would affect the conversion to alternatives. And I generally end up including those operations in my work with the companies so they can make a better transition. And in this case, for example, the anti-spatter the company was using had N-propyl bromide in it. And if they had converted to a water cleaning process, the spent cleaner would be contaminated with N-propyl bromide when you clean the parts that had it on, and there would be a higher disposal cost. So we had to get rid of the N-propyl bromide in the anti-spatter. And just to mention, in general, the commercial anti-spatters on the market contain methylene chloride and not N-propyl bromide. So on the top left of this slide, the picture shows one of the company's parts, which, as you see, can be really complex. And the picture on the right shows the vapor degreaser that Exotic used. The bottom picture shows a fixture a company engineer designed for testing the anti-spatter alternatives. On this slide, the picture here on the left shows the immersion agitation system cleaner bath and the 2 rinse baths that follow it. And the picture on the right shows a temporary pressure washer rinsing station the company needs to use after the 2 other rinses. They need to do a lot of rinsing. Exotic did plan to purchase a better pressure washer station, and they've probably done so already. This slide shows the annualized cost comparison for the cleaning operation. Again, I won't describe the derivation of all the numbers, but the total figures show that the company reduced their cost of cleaning by 81% through the conversion, and that's a lot. And this slide shows the cost comparison for using the N-propyl bromide anti-spatter and an alternative water-based anti-spatter Exotic ended up adopting. As I mentioned, we did test a number of commercially available water anti-spatter products, but none performed well enough for this operation. So I then approached Brulin, the water cleaner supplier, and asked if they'd try to formulate a water-based anti-spatter. And even though they had no products of that type or ever had made any, they decided to try it. And they were able to make a very good water-based anti-spatter. It was also low cost. And they also conducted all the testing necessary for satisfying the aerospace requirements, and that was at no cost to the company. So the company, Exotic, ended up converting to that product, and it reduced the cost for the anti-spatter process by 71%. Now, I also worked with a plating company on the PPRC project. This company, which was a job shop, they used an N-propylbromide vapor degreaser for cleaning polishing compounds from parts that were made of a whole variety of substrates, and I've just listed some of them on this slide. Now, polishing compounds are notoriously difficult to remove, and I knew we'd need an aggressive water cleaner. I also knew we'd need ultrasonics for cleaning the parts. Ultrasonic systems are quite aggressive, so that's why I wanted to try that. We did testing with a water cleaner supplier, and we found a suitable cleaner. And I then arranged for 2 equipment suppliers to provide quotes to the company, and the company has those quotes, but they didn't make a conversion within the time frame of the project. Now, this slide shows the variety of parts the company has to clean on the left. You can see they have some copper, probably a stainless steel, and a brass part, maybe a zinc part. On the right, the picture shows the inside of the vapor degreaser, and that's lowered into the floor of the facility because it's very deep. And the picture on the bottom shows the ultrasonic system. It was a 100-gallon system that I used to do the cost comparison. Now, this slide shows the cost comparison. Again, I'm not going to go into how I got the figures, but the total values show that the company would reduce their costs by 39% if they made the conversion to the water cleaner. Now, the last company I worked with in the PPRC project was a tube manufacturer who made small diameter tubes that are used to transfer liquids and gases from one place to another in aircraft. And the company had a very, very old vapor degreaser when I started working with them. I don't think I've seen a vapor degreaser like that for probably 40 years, and which tells you how old I am. And they converted to a new, tighter vapor degreaser shortly after that. And they did hire an industrial hygienist, and I think she told them that the exposure was too high and that they should do something about it. Again, in this case, we found an appropriate water cleaner. And I was aware of another company in Southern California. They had similar operations, and they had converted to an ultrasonic immersion system some years ago. But the equipment supplier that I was working with and I thought we could use a different operation that would be less costly. So we did testing in a spray cabinet with a specially designed fixture to flush the insides of the tubes, and it worked successfully. We sent the parts back to the company, they cut them apart, and they deemed that the tubes were clean on the inside. The equipment supplier quoted both an ultrasonic system and a spray cabinet, and as expected, the cost of the spray cabinet was the lower of the 2 quotes. Again, the company is evaluating the quotes, but they didn't convert within the time frame of the project. And this slide just shows you some pictures of the different types of tubes the company makes. Some, as you see, are really small diameter tubes. They're like 1/8 to 1/4 inch internal diameter, those small ones on the top left. And most of the tubes have multiple bands. So the picture on the bottom right shows the spray cabinet we used for testing, and it shows one of the tubes in there that's being cleaned. Again, I won't go into the cost detail for the tube manufacturer, but you'll note in this case that the cost of converting to the water cleaning system, it's actually higher than the cost of continuing to use the vapor degreaser. And that's the only one I'm going to talk about today where that's the case. Now, in the HESIS project, I worked with 2 companies in Northern California, and one was a microelectronics manufacturer. The microelectronics were used in medical devices, so the company was subject to FDA requirements. They used a thick film deposition process in their manufacturing, and they needed to remove particles and handling soils several times during the process. They had historically used an N-propylbromide vapor degreaser for cleaning the parts from the process. And partway through the project, I learned that they had a water cleaning process for removing flux from printed circuit boards. And although the cleaner they were using for that wasn't necessarily an ideal cleaner for the thick film deposition parts, I really thought it would be worthwhile to try using it, because if that worked out, they wouldn't need to purchase additional equipment. So we did the testing, and the defluxing cleaner actually ended up working quite well. So I then provided the company with information on the problems with N-propyl bromide, and they gave that information and also the quality control information from the cleaning tests we did to the FDA, and the FDA ended up approving the use of the defluxing cleaner for that operation. So the company converted, and they didn't need to purchase a new system or a different cleaner. So they reduced their costs substantially through that conversion. Now, the picture on the left of this slide shows some of the microelectronics the company makes, the devices. And the picture on the right shows the vapor degreaser that the company had. Now, the next company I'll discuss is a job shop that makes optical components. The company uses materials like pitch and wax to polish the components. And contaminants like that are extremely difficult to remove. The company had been using an N-propyl bromide degreaser for several years. And I had worked with companies in the past in Southern California, and I had helped them to convert to a soy-based cleaner, which is very good at removing those types of contaminants. So I asked an ultrasonic system manufacturer to test the company's parts, and the soy cleaner, followed by a water cleaner, did clean the parts effectively. I arranged for 2 equipment suppliers to provide quotes, and the company is evaluating those quotes. Again, they didn't make the conversion. I did the cost comparison based on the company purchasing the system, which had a larger bath, because I reasoned that it wouldn't be changed out as often, and that would be an advantage. Now, the picture on the top left of this slide shows the pitch that they need to clean. It's an asphalt-like material, and it's black and everything, and you can see that it might be difficult to remove. The picture on the right shows the N-propyl bromide vapor degreaser, and the bottom picture shows one of the components the company makes. The cost comparison in this case shows the company would be able to reduce their cost of cleaning by a couple thousand a year if they were to convert to the soy-based cleaning alternative. Now, in this next case study, I'm working with North Carolina State University Veterinary School Anatomy Lab. This is a really bizarre application. And they have a whole process for preparing animal bones that they articulate into skeletons for teaching purposes. And in the first step, they have to physically remove the gross flesh and skin and things like that. And that's very time consuming and messy, as you might imagine. The second step is a maceration step, which just means more flesh removal, just not surface flesh removal. And for that step, they boil the bones in water, and it might take a really long time, maybe 2 or 3 weeks of doing it over and over. During the third step, they degrease the bones in a vapor degreaser using trichloroethylene. The degreasing has to also be done several times. And if you don't do this degreasing step, fats can leach out of the bones at a later time because they're still in the marrow, and that would be awkward if you're teaching and have this skeleton there. So I knew right away we'd need to use an ultrasonic system for the conversion to water-based cleaner. Again, ultrasonic cleaning's aggressive, but at the same time, we needed to be careful not to damage the bones. And I'd never worked with bones before, so I wasn't sure. But we chose a water-based cleaner for testing, and we got the people at North Carolina State an ultrasonic system so they could do some initial testing on site. And it seemed to work very well, and it didn't damage the bones. And it looks like it's going to be faster than using trichloroethylene. So I looked into it a little more, and we decided to test an enzyme cleaner in the future. These cleaners contain protein materials like lipase, and they're designed for that type of cleaning. So I then found a supplier who would be willing to lend the university an ultrasonic cleaning system for a week to do more testing. So when they get that, we're going to test the enzyme cleaner alone and the enzyme cleaner followed by the other water cleaner we tested. And then we'll be able to compare the results to the original testing with the water cleaner alone. We're also going to do a test to see if a technology called dry ice blasting can clean the gross flesh and skin from the bones faster and more efficiently than doing it with your hands. I've used the dry ice blasting system in other applications like graffiti removal and cleaning industrial molds and also cleaning energized electrical equipment. And the dry ice people have apparently tested the system and they were able to remove flesh from bones. So we're going to do a virtual demonstration of the system and it should be really interesting and it might be applicable for other operations like the North Carolina State University for reducing the labor time and energy for gross flesh removal. There are a lot of operations like that in the country, apparently. This slide shows some pictures of the bones the university cleans. The top picture on the left shows some rhino and whale bones that they've had in the past. And the picture on the right shows the bone in the middle that's been cleaned using the TCE degreaser. And for comparison, you can see that the other bones on the outside of it aren't clean. The bottom picture shows some of the bones that were cleaned in our initial testing. Now, the next case study is a company I worked with in the Los Angeles area many years ago. The company was using a 35-gallon trichloroethylene vapor degreaser to clean valves that are made of a lot of different substrates that I've listed here. And they either refurbished or manufactured the valves. And for the refurbishing, the degreaser was used to remove all kinds of contaminants the valves had on them from years of use in the field, and even things like bakery flour, as you see I've listed. The degreaser was also used to remove other types of processing fluids in the case of the new valves in preparation for brazing or coating. And we tested alternative water-based cleaners and found one that worked well. And the company ended up purchasing a spray cabinet to use the water cleaner. Now this slide shows a picture of the spray cabinet. And as you can see, it has a turntable where you place the parts and that turns around. And the cleaner is sprayed on the parts at high pressure from a spray bar, which you can see in there too. And that's adjustable up and down for depending on how large the parts are. Now this slide shows the annualized cost comparison for the valve company. As I mentioned earlier, the cost information is old, so it's probably not still viable. However, the relative cost information I think might still stand. So the total values in the table show that the company reduced their cost by 18% through conversion to the water cleaner. Now the last case study I'll discuss is a nameplate manufacturer. And I worked with them many years ago, also in the Los Angeles area. The nameplate stock is made of several different materials, which I've listed here, and 90% of it is aluminum, and the balance is stainless steel or brass. They had a 50-gallon trichloroethylene vapor degreaser, and it was used to remove the oil coating on the nameplate stock when it arrived at the facility. It protected the parts from rusting in transit. And the company had a very large workload, huge workload, and they cleaned about 1,000 nameplates per day. So we tested water-based cleaning alternatives and we did find a suitable one. Now, because the company did such a high volume of cleaning, we looked at using a conveyorized cleaning system for cleaning the nameplates. And the system they ended up purchasing is shown here on this slide. And you load the parts on the conveyor belt at the front of the machine. Then they go through a chamber where they're sprayed with high pressure cleaner. And they then go through a high pressure water spray rinse. And it's a recirculating rinse. And then they go through a dryer. And the nameplates come out the other end clean and dry. This slide shows the cost comparison for the nameplate company. And although the conveyorized system was expensive, I think it was about 150 grand with the recirculating rinse, the company did end up reducing their labor costs through the automation. they were able to reduce their total cost by 22% by converting to the water-based cleaner. Now, I just show on this slide some of the issues that have arisen when I've worked with companies on alternatives. Companies virtually always start out wanting a drop-in alternative, but there really aren't any that don't pose health and environmental problems of their own. And I can talk about what all those alternatives are and what their problems are if anybody's interested. And if the companies always use vapor degreasing, they're often skeptical that water cleaners will even work. And so what I find is the testing with water cleaner suppliers and water equipment suppliers can dispel the fears. And those suppliers will do all the testing for the companies for free because they want the business. And suppliers will often also do all the testing to get suitable cleaners aerospace approved. But there are also many water cleaners that already do have aerospace approval. Now, another issue is cost, and I try to make the alternative cleaning systems as low cost as possible. No one wants to pay more than they have to for cleaning, obviously. One of the companies I talked about bought a secondhand system that I helped them find. And as I mentioned, we tested a spray cabinet, which was cheaper than the ultrasonic system for the tube manufacturer. And in a couple of cases, the companies didn't even need to buy new equipment. Finally, when I worked in Southern California, where they have a robust regulatory regime, companies were more open to converting. In other locations, as I found since I've moved to the Pacific Northwest, there are few, if any, regulations. And I found that that offers little incentive to convert, even when you can show companies it's cost effective to do so. So those are just a few things that I've found. Just to conclude then, water-based cleaners are viable alternatives and they're appropriate for the vast majority of companies using vapor degreasing today. Other safer alternatives like the soy cleaner that I mentioned are suitable in certain cases. And you just have to accustom yourself to the fact that there isn't ever going to be a magic answer. And I found that I really have to know a lot to guide companies properly so they won't be heavily influenced by certain vendors who want to sell them inappropriate or unsafe alternatives. Companies tend to trust their vendors, and so they'll ask them, but vendors aren't always that knowledgeable about the problems or the cost of some of the alternatives. And so I try to learn about all that. Finally, there's been a lot of switching from one solvent to another, as each solvent has been increasingly regulated over the years. And really the best option for companies is to get into a permanent solution, so you don't have to go along with the stupid shell game anymore. Now, I just wanted to mention, Linnell said this as well. I wanted to mention some training sessions I'm doing with a nonprofit organization called Green Up in Nevada. And we're going to have 4 sessions on safer solvent alternatives in the April and May timeframe. And I'm going to give the first 3 sessions. The first one is on graffiti management methods. And the second one is on the type of cleaning done in auto repair shops, things like parts cleaning and auto aerosol cleaning. I worked a lot on those things when I was in Southern California. And the third session is going to focus on industrial cleaning and thinning, things like, again, parts cleaning if you have a machine shop, aerosol and non-aerosol hand wipe cleaning. Thousands of companies do those types of operations, and cleaning spray guns and also thinning. And then the fourth session is going to be, I'm invited some suppliers or formulators, and they're going to discuss some of the low toxicity, low VOC alternative methods they have, either a technology. The dry ice blasting guy is coming. I don't think he'll demonstrate flesh removal, but his talk will be interesting, and some of the formulations the suppliers have. So I don't yet have a flyer, but I'll send it to Linnell next week, and she can send it out to anybody in case you want to come. So here's my contact information, and please feel free to call or email me if you have questions about a solvent operation of any kind. And I'm also showing, as I said I would on this slide, the address for the IRTA website, which has the detail on the two last companies I discussed. Thank you for your attention, and I'll be glad to take questions on the vapor degreasing or any type of solvent operation you want to discuss. I think we have time for questions. Is that right, Linnell?
Yes, we do. We do, Katie. I'm going to have Allison, if you want to stop recording now so that